mission scenario. Those of you that are familiar with the GER, the past GERs know what the mission scenario is. It is it shows a view of the next 10 to 15 years with human and robotic missions and where they might go and how they might work, how they might fit together. So we have we reflect planned missions, so missions that are planned. So for example, robotic missions that are planned, EM1, EM2 missions that are planned, and we also reflect conceptual missions that we've been studying together, right? And the missions that are on the mission scenario result in technical architecture work that underpins it to show that the missions are technically feasible and programmatically implementable. But a lot of the missions in the mission scenario are conceptual. They're not specific architectures that we've all decided we're going to go off and build. They're an existence proof, if you will, of things that we could do together to meet our goals and objectives. So you're going to hear in the next series of presentations about the mission scenario that you're going to see in the new Global Exploration Roadmap. The last roadmap had a mission scenario that demonstrated the importance of the lunar vicinity. We had the NASA asteroid redirect mission inside the Global Exploration Roadmap. It was a mission to robotically relocate a piece of an asteroid back to cislunar space for astronaut exploration. And we also had missions around an evolvable deep space habitat. This was a reflection that an infrastructure in cislunar space has been something we've been discussing in the easier for us to talk about a consistent, a common pathway that includes cislunar space and the lunar surface. And you're going to see that in the series of presentations that follow. But one of the things you're going to see very strongly described in this roadmap is the importance of low Earth orbit. So, with the ISS, we are in low Earth orbit. And doing a lot of experiments that not only generate benefits for humanity, but prepare for exploration. Robyn's going to talk to you about that in a minute. We've also been talking as agencies about the importance of a continued presence in low Earth orbit. So you're going to see that in the roadmap. The Chinese, who've newly come to the discussion in the ISEG, are planning a space station with their first launch in 2019. And completing their Chinese space station by 2022. So you'll see that in the roadmap as well. Then lunar vicinity is still important. You're going to hear more about that and how that enables not only missions to the surface of the moon but to Mars. So that's sort of the theme, the overall roadmap theme that you're going to see this time. And the next series of presentations will explain more of the details and share with you a bit more what the plans are. And these are, since this is a NASA community workshop, you're going to see a flavor from NASA. But these are reflective of the things that we've been talking about with the international partners and will be present in the Global Exploration Roadmap. So with that, I'm going to introduce the next speaker. The next speaker is Robyn Gatens. Do we have Robyn? Let's see if there's Robyn. Okay, Robyn is the Deputy Director of the International Space Station Office at NASA Headquarters, Human Exploration and Operations Mission Directorate, and she is going to share with us a description on the role of LEO in the new GER. So Robyn, I'm going to turn it over to you. Let me tell you, first of all, that at the end, I'm going to open it up for questions, and we'll ask for questions from the audience and questions from people online. I will verbalize for you the questions to people online, so I ask you to bear with us at the end while we process questions and get everything together, but that's the way it's going to work. So over to you. Robyn, can you hear me?
Okay.
Yeah. Okay. Great.
Yes, I can hear you. Can you hear me now?
Yes, loud and clear.
Okay, great. Well, good morning, everybody. This is my first time, I think, to interact with this group. I think you're more familiar with Sam Shamimi, who is presenting to the NAC at the exact same time that this was scheduled. If it looks like I'm sitting in a hotel room, that's because I am. I'm also in Florida, but Sam and I have some other meetings planned here, down here. So at the moment, I'm camping out here in the room and not at Kennedy Space Center. So as Kathy described, I'm going to be talking about the role of low Earth orbit in this global exploration roadmap scenario. So with that, I guess I'm controlling. Am I controlling my slide? I know Ricky trained me very well, but
just use the bottom of that slide set.
Oh, the arrow. There we go. I was using my laptop arrow. All right, so sort of as a way of introduction and a kind of a bottom line up front, I did want to emphasize that in the space station community, all of the partner agencies are active in the International Space Exploration Coordination Group in planning for the next steps beyond low Earth orbit. And all those partners believe that missions to the lunar vicinity can begin while we're still operating the ISS. There is often talk of an either-or scenario. Either we can go beyond low Earth orbit, or we do low Earth orbit, but we can't really afford to do both. And I think all the partners agree that that's not the case, that we can execute missions while still doing work in low Earth orbit. And the updated GER will make that clear, that even as we extend beyond low Earth orbit, that LEO will remain an important destination for all agencies, including non-ISS agencies. So with that, I'm going to go into just kind of where we are today on the International Space Station, and then a look ahead and some of the planning that we're doing and what that landscape looks like beyond the current horizon. I think everyone's aware of the many roles of the International Space Station, what an achievement it is. The four main thrusts of the space station that we communicate about are, of course, the conducting research and technology demonstrations. It's a test bed to get us ready for the next steps beyond LEO. So we're doing all the advanced technology development that the ISS really enables, such as the life support system was mentioned, that I'm very involved in, and I'll show a slide later on that plan, and as well as the human research capabilities that will be needed to enable humans to live and work in space on these long duration missions, as well as other technologies. So it's a really critical step in what we call that phase 0 on the pathways slide, that we execute this mission to go beyond low Earth orbit. And did you guys lose me? This is an experiment for all of us. I'm not sure where you lost me. I was discussing the use of the ISS for conducting the technology demonstrations we need to go beyond low Earth orbit, which is really the first bullet on this slide. The next major thrust is we're trying to enable a commercial market in low Earth orbit. So we're trying to, I'll talk a lot more about that in subsequent slides, but we're really trying to be very intentional about leveraging the ISS in order to do that. And then, of course, we're advancing benefits to humanity through the scientific research that we're conducting on the space station. And then it's our basis for international cooperation. The partnerships that we have on the International Space Station will continue as we go into deep space and the area around the moon and onto Mars. So we definitely are using those partnerships as our basis for continuing. So by the numbers, we've been continuously crewed since November 2000, so just past our 17th anniversary of continuous crew on the space station. I like to have people think about high school seniors today have never known a time when there haven't been humans in low Earth orbit. And that's pretty amazing. We've had over 200 different crew members from 15 countries and over 2,000 total research investigations and counting. And then I think we've shown through our partnership that we have a healthy and resilient cadence of cargo supply that it has been able to sustain the space station even when we've had failures. So now I'm going to get into kind of where we are today with ISS and LEO, and then I'll step off of that and sort of get my crystal ball out and talk a little bit about what we see on the horizon as far as what's coming in LEO. So where we are today. I just mentioned, continuous human presence has been sustained over 17 years, and we will have, today we have normally 6 crew. When we have our U.S. commercial crew providers come online very soon, then we'll have the capability of adding an additional crew member with more flight opportunities. Mentioned our international partnership. Our intergovernmental agreements have been in place for nearly 20 years. And all partners are supporting ISS operations to 2024 now. Our research and development is vast. It spans all areas of scientific disciplines, physical sciences, earth science, space science, human health, many, many others. The users have been greatly expanded into private industry and other government agencies. Some examples there: pharmaceutical companies, materials, manufacturing, and many, many others. And we're even seeing very non-traditional users now get involved through our national lab. That national lab investment is enabling new innovative uses of LEO. CubeSats is one great example, and is enabling new implementation partners and new commercial suppliers. So a whole healthy economy is building up around the ISS. Speaking of the commercial markets, so we have our U.S. Cargo suppliers now launching today, and then soon we'll be joined by our commercial crew providers. The ISS supports 14% of the world launch market. I think that number may even be higher if you take into account 2017. So significant portion of the world launch market goes to ISS today. And we are seeing commercial research and technology development supply and demand increasing. I will caveat that to say we're seeing a very healthy supply side. The demand side, I think, is still emerging. currently today, private industry and other government agency users are probably not in a position to pay for the capabilities that the national lab is providing today, such as crew upmass, transportation, crew time, power, etc., without the ongoing subsidy by the government. But there is great, also we're seeing a lot of interest by private sector companies in establishing commercial human platforms in LEO, beginning with potentially attaching to the space station, eventually establishing human platforms in LEO apart from the space station. Seeing great interest in that. So that again, that supply side remains to be seen whether the demand can support those private platforms without continuing government support. For deep space and long duration exploration are requirements for the human research and also technology and system demonstrations for habitation systems for which we're using ISS as a test bed. Our plans are underway, and we have plans to complete all of that research and technology demonstration work by the mid-2020s. Here's that example for my specialty, which is the life support area. I also lead the system capability leadership team for the agency for life support systems. And we put together a plan. I know this is a lot on one slide to take in, but we are evolving the life support system that we have on the space station today into the system that we believe we will need to support deep space missions beyond low Earth orbit, where we cannot rely on that supply chain from Earth. And this slide depicts whenever you see an up arrow, that's when we're flying something to the space station, either an improvement to an upgrade to a system we already have, or an alternate technology to something we already have, or a new capability that we don't have on the space station today. And whenever you see a diamond, that's when we're making a down select or a decision between technologies or between paths. So our goal is to, and we've already started, is to evolve this system to our exploration ECLIS, we're calling it, by 2021-2022 timeframe, so that we can start a long duration, and we've lost audio. Okay, I'm back. Thanks, Erin. So that we can start a long duration test of that exploration ECLIS system on the ISS. We'd like to run that for multiple years because we've learned that one of the key challenges with life support systems is the reliability. And while we have the luxury of flying spare parts and replacing things, today on the space station, we know we won't have that same luxury when we take the system to deep space. So it needs to be very, very reliable, as well as less dependent on consumable resupply. I'll also point out on this slide that we are working with our international partners, ESA, JAXA, and Roscosmos, who are all involved in life support development as well, and have plans to fly technology demonstrations to the ISS. And so we're coordinating all of that and working on joint standards together so that it's possible that we can pick and choose between technologies that we might put together for our exploration ECLIS in the end that can plug and play with each other. So establishment of some common standards is something we're working on today, as well as enabling all these parallel demonstrations. So that's one example of how we're using ISS today to get us ready for exploration, and a very necessary step. If we didn't have this test bed in microgravity, it would be much harder to prove that we're ready to go with just ground testing. We have learned through operation of the ECLIS on ISS that that we've learned things once we've flown it on orbit that we would probably never have learned through just ground testing. So we feel like it's really critical to have that microgravity platform. So fast forwarding to 2024, this is where we get out our crystal ball a little bit. By the way, this photo is a time-lapse photo that someone sent us from the space station flying overhead. One of our Spot the Station folks took this. So looking forward into the future, there's things that we have a fair amount of certainty about. That by 2024, we will have operated the station and had continuous human presence for over 24 years. China will be. Oh, bad feedback. China will be operating their newly completed space station, and that'll expand opportunities for conducting research in low Earth orbit. Our U.S. commercial crew flights will be happening and have enabled greater flight opportunities to the ISS and potentially other platforms in LEO. And our exploration-related human research and technology system demonstrations will be nearly complete. As I said, we're targeting the mid-2020s to be done with those. So our focus will be shifting to deep space at that time. I will caveat that with saying that we have been thinking about and trying to forecast what we expect to still need to do ongoing in LEO, even though we'll essentially be done and be implementing these systems in our new deep space spacecraft. We do expect to still have some ongoing uses in LEO to continue to support those long-term deep space missions. For example, if we are going to upgrade the life support system for a trip to Mars, we will want to test those upgrades in a system in microgravity before we implement that sort of a block upgrade. So having a platform, an ongoing platform in LEO that will enable us to do those tests will be important. So we're trying to kind of scope that out, and so more to come on that kind of forecast. And then we expect by 2024 that human spaceflight missions in the lunar vicinity will have begun, as Mark was describing earlier. So the things that we have less certainty about, a little cloudier crystal ball. Number one, whether or not the private industry users for ISS will be able to pay for the services that we're currently providing through the National Lab, the crew time, the upmass, those kinds of things. Today I think we're starting to see some of that, but whether or not we'll really have transitioned to those folks having the ability to pay is a little bit uncertain. Whether or not we've really established a commercial market demand that will be able to sustain private commercial platforms without that ongoing significant government investment. We've looked at all kinds of kind of forecasts and potential markets and tried to do some analysis. And if we had to say today, it looks like that although we can project significant demand, that it probably is not going to be enough to sustain a commercial platform without some ongoing government support. So we held a workshop this summer with our stakeholders in Washington, D.C. to talk about the future of ISS. This is all related to a congressional report on ISS transition that we're getting ready to finish up and deliver to Congress. And part of that process, we wanted to hear from our stakeholders what's important to them as far as transitioning beyond low Earth orbit and the future of low Earth orbit. And here were some key takeaways from that workshop. The stakeholders acknowledge or would really like to see a formal acknowledgement and policy on the future of LEO. So a LEO human spaceflight enable commercial policy, something definitive would be very helpful in building business cases. Also, I feel like it was important that the government maintain its demand for LEO capabilities. That kind of goes back to without ongoing government support, it's kind of unlikely that these private platforms will be viable on their own. So some level of government demand in LEO would be very helpful. A desire for a pricing policy for LEO services. Those things that are provided today, such as crew time and upmass, there's a desire to kind of know what is the cost of those things that are being provided for free today, so that they can work that into those business cases. And then finally, kind of the big takeaway is we were not hearing anyone advocating for hey, we need to get rid of ISS in 2024. That if we do consider options for ISS beyond 2024, that transition needs to be gradual and well planned and not an abrupt end. So that was encouraging, and that's kind of the direction that we had been thinking as well in planning for a logical transition. So getting into that, what would the future of LEO and that transition sort of look like? We can talk about, I'll say we don't have an answer today. Even in the report that we are delivering, we don't prescribe an answer. We kind of lay out this landscape and talk about considerations, and then we're looking for some feedback from our stakeholders on what kinds of policy and considerations are important to the nation and to our international partners as we think about potential options. But when we talk about those options, whether we extend station, whether we transition off of station to private platforms, or what do we do? These are some of the considerations that we have to take into account. So the timing of this transition, we don't really want to do anything that will disrupt our completion of getting all these exploration-related research and technology development, things that require the ISS as a platform done. So we need to be pretty complete with that work before we transition to a different model for LEO. We need to see demand from government and private industry, more demand being for activities in LEO, and that demand being able to support private LEO platforms and the associated transportation costs, which are the big cost. And then finally, we need to have established this sort of next step beyond LEO and human missions beyond LEO, and be executing those human missions beyond LEO. The one thing that we really do not want is to transition off of ISS and have a gap in human spaceflight. The next thing is we need to consider, of course, affordability in the larger human spaceflight exploration context. So what kind of ongoing LEO support is affordable when you combine it with the cost of what's next. Then there's a whole host of policy considerations. What is the role of the government in fostering research and development in low Earth orbit and with non-NASA government agencies. NASA isn't alone in this whole LEO economy, and I think the Space Council is a positive sign to bring in other government agencies who also have a stake in space and low Earth orbit to help us figure this out and what is our role. We have a number of policy issues on if we're going to transition to a more commercial model for space station, then there's a number of policy issues we need to address there. Today on space station, we have standards for the kinds of research that we fly through the National Lab, where just something that is a purely commercial payload is not necessarily considered, our best and highest use. So do we modify that policy and to try to enable more commercial activity? And then looking at various public-private partnership models, and there's a whole host of potential models as we transition that we could look at. So a whole bunch of options there. And then, as I mentioned earlier, our government needs for future LEO platforms is sort of forecast of what our ongoing needs in LEO in NASA and other government agencies would be. And the work that we've been doing in that area kind of teased out that there could be different kinds of platforms that could satisfy ongoing government demand, and that could be a continuously crewed long-duration platform like space station we have today, or it could be a platform that's continuously in LEO, but that humans, it's sort of crew-tended. Humans come and go, but aren't there all the time. And then there could be what we call sort of a short-duration platform, or a sort of a sortie or shuttle model where flights go up, maybe spend a couple of weeks and come back down. And so when looking at these different kinds of platforms that match or don't match our government needs that we can kind of forecast is important. Other agencies are increasingly talking about future needs in LEO as well, so we'll be continuing this discussion about what kind of needs do we see in LEO, what kind of platforms meet those needs, and then trade those options. As far as the health of the space station, that's definitely a consideration. We have all of the elements were not launched at the same time, and so particularly the later elements have considerable structural life after 2028, even into the 2040s potentially. Some of the systems, including the solar arrays, will need to be replaced by the end of the 2020s if we're going to maintain the current configuration. But overall, the station is healthy. I would say that the maintenance has been less than we had originally anticipated, and we've shown that through resupply of spare parts we can keep it healthy. I guess this just might get off the stage chart. So I would say definitely NASA and our partners are looking more and more at a future where we have human activity in LEO ongoing, whether it looks like a continuation of the space station that we have today, or maybe a different operating model for that space station, whether it means private platforms, a combination of those things, kind of remains to be seen. But we believe, again, that we need to continue human activity in LEO to some extent, even as we venture out into these future missions. So with that, that's all I had to present, and I'll take questions. China.
So I have a question I'm going to turn it around a little bit and ask the question of Bernard Hoffenbach from ESA. But the question is this. What you've heard from Robyn is a decidedly U.S. view, but it reflects the kind of things we're talking about with our international partners, right? And I believe, and not only the ISS partners, but the other, not only the ISS partners, but also the other space agencies that are engaged in the ISEG and the exploration work. And what we find is that there is definitely a consensus that there is going to be an ongoing government need for access to LEO for a variety of things in the future and long after the ISS. And this is a message we intend to say very strongly in the next GER, just to help encourage private sector entities that are looking for the fixity of government intentions to help stimulate the commercial LEO market that Robyn described and that we all hope to obtain. So my question, Bernard, is I know you and ESA have been doing a lot of work on a lot of thinking on this topic, and could you share with us briefly what ESA's thinking with respect to future demand for LEO, its nature and size, and whatever you're willing to share?
Thanks a lot. Yes, in fact, ESA has already, since 4 or 5 years, started to reflect on what would be the interest of Europe in stations post-2024. Because today ESA is committed to participating in ICE operation up to 2024, and we have done numerous user consultations. And in the end, in fact, our strategy for LEO post-24 is very simple. We want to sustain a user-driven application scenario of platforms post-24 that includes ISS and other platforms, because we see there's continued interest from ESA, certainly, in research. It's the same we're doing today. We have built up significant community which does research in low Earth orbit in field of life and physical sciences. We see also increasing demand for technology demonstration, even applications. But ESA also has an interest in continuing astronaut missions to low Earth orbit, because it's very clear that as we think about beyond LEO missions, there is a very limited opportunity for the European astronaut mission. That's certainly also an important aspect. Now, clearly the type of utilization, the type of infrastructures might evolve. We probably see more interest in long duration missions with astronauts. We may see more automation. We see probably need for more repetitive experiments. So the type and the community is maybe evolving, but we definitely see an increased need. And in this context, we also have recently started a call to industry to come forward with ideas of what could be post-ISS platforms, which could build on the model of what we call a commercial partnership or public-private partnership. We clearly also looking in scenarios which, of course, will allow us to extend our participation in ISS beyond 2024. And we put in place some Pathfinder commercial partnership linked to ISS, where we also try to understand what kind of governance model we can put in place with industry to work on the basis of a commercial partnership, how this partnership help us maybe to nurture non-agency funded utilization, and how we can maybe reduce the risk for future investments. Having said all this, for sure, I think our strategy very clearly asks us to continue a presence in low Earth orbit beyond 2024 and even beyond ISS, whatever lifetime of ISS might be.
Thank you, Bernard. Okay, in the interest of time, I'm only going to read one more question, and the question comes from Andrew Jordan. Robyn, is there a need to simulate long-duration human spaceflight into the solar system by having more crews stay on ISS for at least a year? Are there more year-long missions in the works? So we're not hearing you, Robyn. Hold on.
Yes, good question. Our human research program guys actually have laid out a plan. Shoot.
It's some bad luck today.
Can you hear me now? Can you hear me now? Hello?
Question?
Okay.
Yeah, loud and clear.
I have people typing they can hear me. Okay. Can you hear me, Kathy? Okay, so yes, our human research program folks have laid out a plan that calls for more one-year crew missions. We haven't figured out exactly when we're going to do those yet, or put them in the plan definitely, but they yes, they believe they need
Thanks, Robyn. So
more.
can I ask
And I
everybody
think
to
the
join me in
number
thanking
potentially
Robyn
is
for
up
the
to 5
presentation?
one-year crew missions to execute their plans.
Okay, appreciate it. So our